Thank you all for being here. I'm really excited to talk about Bitcoin and the blockchain. So to get started real quick, I don't know if you guys noticed, but in the little guide, it has my picture with Richard Branson. And there's one reason why I did that, and that's because I paid a lot of money for that picture, so I have to use it whenever I can. I was actually invited to go to Richard Branson's private island to talk about blockchain technology and what the future use cases are. But I had to pay my own way, it wasn't cheap, and so like I said, one reason I went was to get this picture. So I had to use it. So real quick, the presentation overview. First we'll talk real quickly about the introduction, an introduction to blockchain technology, Bitcoin, what it is, market fit of blockchain technology within the IoT, examples of pairing blockchain technology in the IoT, and then where can you learn to develop within the ecosystem, as well as what companies are providing kind of sandboxes to play around. So first off, blockchain technology. Who here has heard about the blockchain? Okay. Who feels very comfortable talking about the blockchain? What it does, how it works? Okay, so not very many people. Two major parts of this technology. One is completely decentralized. So the idea is having individual nodes decentralized around the world that work together running a consensus algorithm. So instead of having one database and one software that everybody is running individually in a siloed node, you're all running this consensus algorithm and you all work together. So you share data and you come to a consensus to figure out how to move forward. So nobody owns it, and it's it's distributed. Now the blockchain itself, how it works is you have individual blocks. Each block is a block of data. That data gets submitted to the community, as you see here, that is decentralized and distributed. That community, the computers run the algorithm, and they say, okay, what is in this block of data? And they confirm that block of transactions. Now, transaction could be anywhere from a currency transaction, financial transaction, to sharing information. And so this is all cryptographically secure, and you'll see that as you move up the blocks here, the blocks never go away. So there's actually a public ledger that you can go view transactions. I'll talk a little bit more about that in my next slide talking about Bitcoin, but what this does is it allows each new block to be confirmed against every block that's ever been confirmed, all the way up. So it makes it very secure, it makes it very hard to game the system, to hack it, and make changes to previous transactions. So now let's talk real quick about Bitcoin. Bitcoin was really the first application built on blockchain technology. It's a digital currency. So I have a Bitcoin wallet, you have a Bitcoin wallet, and I want us to send you value, Bitcoin. I can sign that transaction with my private key and send that Bitcoin to your wallet. Each of our wallets is really just a public address. Those public addresses are found on the blockchain. So when I send you Bitcoin, on the blockchain you see my public address and your public address, this value. All right? Now those nodes that are running the algorithm say, does this person actually own these Bitcoin? Has he tried to spend these Bitcoin previously? Has he sent them to anybody else recently? And so that's how you can secure the blockchain to make sure that nobody's gaming the system and trying to double spend the currency. So Bitcoin is being adopted worldwide, and there's a lot more to the back end of Bitcoin that we can talk about outside of this presentation. So let's talk about blockchain and IoT. So some use cases, let's talk about unique device identity. So each device, as we know, as it's connected to the internet, needs to have an ID, so it knows how it's connecting, what device it is, who owns the device. So that can be done on the blockchain. Now again, device history. So anytime that device connects to the internet and shares data, be it financial data or identity data, or just a document, that history is found on that public ledger, on the blockchain, and is secure on that blockchain. Data storage we'll talk about a little bit more, as well as data analytics. So those are the main pieces I want to talk about today. So let's talk about a few examples. One is a company called 21 Inc. Anybody here heard of 21 Inc.? One person, sweet. Okay, that's perfect. So 21 Inc., they're doing something really remarkable. So they are using phones. Let me back up one step. So those individual nodes that are part of the network of the blockchain, what they're doing is they are confirming transactions. When they're confirming transactions, they are actually compensated with new tokens. With Bitcoin, it is actual Bitcoin, the digital currency. So they actually get paid to confirm transactions. So what's happening is Inc.21 is working with cell phone manufacturers to put a mining chip, it's called mining when they're confirming these transactions, put a mining chip in every single cell phone that they develop. What that does is it allows each of us to mine Bitcoin from our phone without doing anything. It just automatically does it. So it participates as a node on the network. As it helps confirm transactions, it gets Bitcoin. So you will have a Bitcoin wallet on your phone, out of the box. You don't have to do anything. Once you have that Bitcoin, what they're doing is they are making it simple to use that Bitcoin. So for one example, let's pretend there's a Wi-Fi network. It's been very difficult to monetize Wi-Fi networks. Let's say you're Barnes & Noble, you want to provide a Wi-Fi network to those who are sitting in your cafe, and you'd like to make a little bit of money off of it. You don't want to do it for free. Well, right now with microtransactions, because you don't want to charge too much, then nobody will come in and use your Wi-Fi. With anybody that has this phone, that Wi-Fi network can automatically be paid in Bitcoin currently and other digital currencies in the future for that Wi-Fi connection. So you're basically paying for that connection. And it can be used in a lot of other ways. To date, they've raised $121 million pre-launch, which is a pretty decent amount of money. And if you look at who the investors are in 21 Inc., you'll notice that there's some big names here that can actually make this happen. And so it's going to change the way that we interact with each other. Devices will be working on our own behalf, actually making financial transactions. So let's go to the next one, the beer keg. Okay, so I was at a conference and I was speaking to a representative of Intel. He was telling me, well, he showed me that he has this scale that a keg sits on, right? It reads the scale. It reads the keg. How much beer is left? All the analytical data that you would want in an IoT application. We continue the conversation and say, well, that's great. You have all this information that you can use. But what if that scale can actually reach out to different distributors? Distributors that have an identity on the blockchain that individuals can actually rate, or other companies can rate as good or bad distributors based on the price of their kegs, based on their delivery mechanisms. And on the behalf of the owner of the bar, it will actually reach out to these different distributors, figure out which one it wants to buy a keg from. It will pay them in Bitcoin. The wallet from the scale automatically pays the distributor. The distributor then sends a new keg. It's all automatic. It's all happening in real time, and it's based on an IoT device, which is this scale. But what's amazing about that is we're talking about a blockchain application along the whole path here, from scale to identity and reputation for the distributors, to micro transactions and possibly big transactions using a digital currency. That was again a discussion with an Intel representative. Who knows if they're moving in that direction, but obviously they are moving in the direction of IoT and providing at least half of this solution currently. Quickly, autonomous agents. There's a really fun use case here. So imagine in the future you have a car. This car is not owned by anybody. It's programmable. It's programmed to run off of a network, like an Uber network, where somebody is looking for a ride, right? It's the actual car that's looking at that network and knows who is looking for a ride, and maybe they're actually bidding for a ride. And they're saying, well, I want to be picked up before the next guy, so I'm willing to pay this much more for a ride now. The car, self-driving car obviously, sees that there's somebody that needs a ride. It matches the network and says, I will provide that ride. It shows up, picks up the passenger. The passenger automatically pays the car, again in a digital currency, similar to, again, Uber, where the transaction happens automatically. Takes that person, drops them off, and now looks for the next ride. Well, now the car is completely smart, so now it knows I may need an oil change. I may need new tires. It knows because it's monitoring everything. So when it needs maintenance done, it goes on its own to the mechanic to get the work done. And when it needs to be charged, because it's going to be electric, it goes and charges itself. So it takes itself off of the network and it's not an available car to pick up passengers. Well, now let's say within the program, this car can actually make money because they charge more than what the expenses were, right? For repairs, for charging, and everything else. The car says, I have all this extra money, nobody owns me, there's no profit, looks like there's enough demand on the network, another car is necessary to fill the demand. So it purchases another car. And now that car basically works for the first car, doing the exact same thing. Now you may get to a point where there's more supply than there is demand. It can take itself right off the road. It can go, park itself, shut off for a certain period of time, pop back on 2 weeks later and say, all right, network, is there demand again? If not, shuts itself back off. All of this happening autonomously, no ownership, no humans running the network. Now, there's a lot that would have to happen to make that work, but thanks to some of the blockchain technology and the communications that are available there, it's possible. So now let's talk about storage and analytics. So Storage Labs was here last week. They're looking to move their headquarters to Salt Lake City. What they are is they are a decentralized cloud storage service. So instead of having all of this data, I mean, think about all the data we're going to have coming in from the IoT. Massive amounts of data. What do we do with it? How do we secure it? Do we want to have huge server farms, all over the country that are being maintained by centralized groups? I would say no. I think there's a better solution. Storage Labs is one of those solutions, and what they do is they allow individuals that have additional hard disk space to rent that space to the network. So now anybody who has additional storage space can put that storage space on the network and say, I have extra storage space. Storage Labs then says, okay, anybody who's saving documents or saving data, let's encrypt it, let's split it up into millions of pieces, split it across the whole network, and that's how we're going to hold the data and store the data. Again, that way you don't need these huge data farms and storage farms. You can actually use individual computers and use what's already out there. So that's one piece of it. Well, now once you have all that data, what do you do with it? We talked just a minute ago in the other room in the panel discussion of there's all of this data and a lot of it is noise. How do we actually pick out the right information that is usable? So NewReal is a platform. As you can see, it's a decentralized big data marketplace. So what happens is you may have a lot of data based on the application you provide. NewReal, what they do is they allow individuals and companies to develop AI algorithms to crunch that data. to do the data mining and come out with outputs. So you as the company with all of that data, you can input that data. Different nodes compete with each other to have the best AI algorithm and give the best outcomes. So it's kind of a predictive market. And those AI algorithms actually get compensated for having the best algorithms. And as the best algorithms rise to the top, people start copying those algorithms, they start implementing those algorithms and adding additional computing power to them. And so now you have a distributed AI marketplace to crunch that big data versus just trying to do it internally and find outputs yourself. You can kind of crowdsource the output of the data. So, blockchain development. Microsoft is currently in the space, and I'll talk about each one of these individually. IBM, those are kind of the two big names right now. And then you have kind of independent groups like Blockchain University. Because I want to talk about Blockchain University kind of individually in a second, I'll just mention that is a developer university. You can sign up, show up, learn about blockchain technology, what are all the different platforms, how to create applications on the platforms. So there's lots of tools online where you can actually learn blockchain development. So let's look real quick at Microsoft. In October 2015, they launched the first blockchain as a service. Most people don't know this, but that's becoming a term fast. Okay. What they do is they provide a sandbox to interact with different technologies because there's different people developing different blockchain technologies. So how do you try them all? How do you know which blockchain platform to build your application on? Because there are differences, and some of those differences are based on the consensus algorithm. What Microsoft does is they actually certify the blockchain marketplace. So those partners is what they call them. They actually vet those partners, and they say, okay, we don't want just anybody to be able to post their technology on our platform for others to learn on. Let's make sure they're the kind of top of class. So now clients can deploy either in Azure or in a local data center via its platform, and they do have cloud solutions available. So if you're looking to investigate blockchain technology and figure out if it's a good platform for what you're building, Microsoft provides a solution. Now IBM takes a little different approach. Instead of providing a sandbox with all the different technologies in one place to kind of play with, so they launched just last month. They have created their own consensus algorithm. And one of their major, points of differentiation is they're looking at permission blockchains. So the blockchain that Bitcoin runs on is permissionless. It is anybody can participate. Again, public ledger, decentralized across. Anybody who wants to run the full Bitcoin client can do it. With permission blockchains, each individual node in that web kind of has to be approved. They have to be given authority or permission to participate as a node on the network. So it's a different idea. You can read up on it, talk to me about it if you like to see what the ecosystem thinks about permission blockchains versus permissionless blockchains. So that's what I mean by their own consensus algorithm. So one big thing that they do is they actually provide developer consulting services. So if you're interested in, again, researching blockchain development, you can reach out to them. They'll have consultants that will walk you through it and sometimes actually help you build the applications that you're looking to build. So you can create, deploy, run, and monitor your applications on the IBM cloud. And one thing that you may want to look into is IBM partnered with Samsung. About a year ago, they announced Adept, where you can actually do decentralized IoT, and they explain a lot of that at this web address. So if you want to learn more, there's the place to go, and they'll talk about blockchain technology and the IoT specifically. That's my presentation. I know I said a lot and I kind of ran through this presentation pretty quick. I think I could spend hours up here talking individually about different applications and different ideas that are being developed in the space. But what I really wanted to do today was just kind of open your mind to what blockchain technology is and how you may be able to use it in the applications you're building in the IoT. Appreciate it.
All right, thank you, Brian. Have time for one or two questions. Maybe Eugene can start sitting up for his while he's asking questions. Ed?
Okay, when you talk about, it's distributed as far as the checking.
Yeah.
How many places is it actually checked?
Sure.
Is it all the nodes, or is it just a sampling of nodes?
Yeah, so again, it's going to depend on the algorithm and which blockchain you're using. But in general, the transactions are being shared with the whole community, right? All of the nodes.
Okay.
That's right. And then what happens is the miners, those computers, those individual nodes, are racing to solve a cryptographic mathematical problem to say, yes, we were the ones that actually solved it and confirmed this block of transactions versus the whole blockchain.
Okay.
And with an open blockchain platform like Bitcoin, you have tens of thousands of nodes. With a permissioned blockchain, you may only have hundreds. And so the level of security and things like that changes based on the number of nodes that are out there, right? So that's something to keep in mind.
So the miners, then, they solve it, the algorithm, check the whole chain, but other people can check it too.
You bet.
Is there anything that, like, if two miners got a different answer, what would happen?
Well, so it is time-stamped as well. So they'll say, okay, which one came up with it first, right? Now, there are situations where one block was reported and it was in a whole different part of the world, and so it got reported, but maybe it wasn't ultimately correct. So what happens is you have two kind of chains going at the same time until one of them proves to be the correct chain, and this one kind of gets orphaned, right? It gets cut off, and then you follow the right chain.
Okay.
So I'm not the most technical person. I'm more on the business development side, the entrepreneur side, and business ops side. There's people here that I can introduce you to if you want to get into the weeds of really the technology of it. But that's kind of the base idea.
Quick question. So do you envision one big blockchain or siloed blockchains that might talk to each other, like the autonomous car example?
Yeah.
I mean, I would imagine that would be on its own network with its own blockchain, right?
Sure,
Will it talk to other ones, or what do you envision?
Well, there's a lot happening in the ecosystem right now around that specific topic. So what can happen is on the blockchain you can build additional layers on one blockchain. So you have the Bitcoin blockchain, right?
Yeah.
Well, let's say you want a specific type of transaction that maybe the Bitcoin blockchain isn't the best for, right? You need faster computing. You need more transactions to be confirmed at a time, and so there's some limitations. There's some groups that have built a second layer to the Bitcoin blockchain. So it looks like it's its own blockchain, but really what it is it's tagging kind of metadata to different transactions and anchoring it to the Bitcoin blockchain. And so there's different ways to kind of spread that out. But what's happening is we're seeing a lot of individual groups creating new blockchain technology that have nothing to do with the Bitcoin blockchain. And I don't think that's going to change. I think that's going to continue to happen until we see a reason, until people stop doing it. And I don't know that that's going to happen. I think there's going to be a lot of different blockchains, and I think there's going to be a lot of tools to connect them. That's my personal opinion. I don't think there's going to be one blockchain that just wins out and everybody uses it. Yeah.
Cool.
Well, it's in this computer software programming, you have so many languages just because somebody wants to create something new.
Right, that's right. Yeah.
You seem to have an opinion before about BAS and BAS, but you didn't really go into it. Do you have a moment now to give us some insight into what you're thinking?
Yeah, I'm a fan of open source, and I'm a fan of big networks, not permissioned blockchains. I think maybe there's a place for permissioned blockchains, but some of the value proposition of blockchain technology is having that many nodes, that many touch points, that many opportunities to make sure it's right. Part of the point of Bitcoin is to not have a centralized anything, right? And we start getting into permission blockchains, you're centralizing it again. So it's like, well, can't you build that without blockchain technology? Don't we already have that? There's a lot of banks that are coming together to form kind of a consortium and what you're seeing is there's like 47 banks, world banks that have come together, and they're trying to build this blockchain technology, but they want it to be permissioned. Okay, well, so now you have 47 banks, they all work together on this blockchain, but to have an attack on a blockchain technology, you need like 51% of the whole network to approve kind of an attack, right, on that blockchain. Well, if you only have 47 people involved, that doesn't take very much to cause problems if you wanted to. Whereas if you have tens of thousands of nodes, you really have to work hard to get consensus to change anything.